Awesome. Okay. First thing I want to say is I'm going to do something slightly different than most of the talk you've seen so far. How I've set it up is I'm going to be mostly working in a terminal on the screen. And if you want to follow along with slides, you can go to slides.joshwilliams, that's me, .name, and you actually bring up, it'll have the slide deck on there. And because me saying to go ahead and move slides would be kind of tedious as we go along, it actually is set up, well, as soon as I switch over to the terminal, that it will actually move along with the presentation on your devices. So it should work on your laptop, your phones, and all that stuff. If you really want to. If you're low on battery, you don't feel like it, the slides aren't really that important, but it may just help. So anyway, on to the more interesting stuff. So who am I? My name's Josh Williams. I work for a company called Endpoint. We do consultation mostly on high-end e-commerce websites, although we'll work on just any websites. We have a number of divisions. We have a Postgres consulting division, in which I'm a member of the team. We have an ops team. I'm also on that, and a number of things. We don't have a lot of Python people internally, unfortunately. I am one of the few amongst a sea of Perl and Ruby type people. So if inside your corporation's organizations you have fights on the Vim versus Emacs type of stuff, that pales in comparison to the fights we occasionally have. But I mean, whatever, it's all open source, and that's the key part. So let's see. Why would we want to use Postgres? Why would we want to use Python? In general, both. Actually, before I go, is that size okay for everyone, especially you in the back? Can you see the text? Okay. Good. Awesome. Okay. Excellent. Python. Powerful. It's very, very fast as a language. Feature-rich, and extremely easy to learn. Postgres, in contrast, is powerful. It's very, very fast. It's very feature-rich, and it's easy to learn mostly. I think so. But then again, I've been using it for many, many years, and it's actually it's really not bad. Once you get into it, if you come from someplace like MySQL or Oracle or some other type of database, you might have. I don't want to say bad habits, but just different habits that it gives you a little bit more of a learning curve than you might have if you weren't just starting from scratch. So, why PL Python? I should mention that PL Python is a way of writing Python code inside your database. In general, you want to get your code as close to data as possible. So when you're writing a function inside the database, you can't really get it any closer. Very likely, you're already using Python outside the database. So if you're in that frame of mind, you're already writing Python. Why not write Python inside the database as well? And if you're already doing any other type of procedural language functions, but PL Python can do some things that other languages can't do. Actually, I'll get into that a little bit more later. But mostly, that centers around the rich selection of modules that are pre-written and available for Python. As I'm kind of doing this as mostly a quick tutorial, I want to at least mention how to do the installation of it. In my little test database here, we are in a PSQL command shell, by the way. I've already got installed, so I'll just create a new database. A little temp one and switch over to it. So in versions, I think as of 9.0 and greater, We're on 9.3 on this. There's a nice functionality called a create extension, which wraps languages installation, various utilities that you can just download and get up and running. So it makes it really easy to install things like that. Older versions you would create language, but in this one we would do create. No, we don't want to do create language. Run 8. We're not on 8.4 or anything anymore. Create extension. There we go. PL Python. And it's actually PL Python U, and I'll get into that in a second. You guys in the back can't see that. The older versions, as I said, if you happen to be running, and hope you're not, but if you happen to be running 8.4 or earlier, for example, we would do PL Python. If we wanted to do PL Python 3, we would do that. And to see what's installed, there's a view PG language which shows everything that's installed on the system. The differentiation between Python 2 and Python 3, by default, PL Python, if you install that, I think it defaults to 2, but I think that's just really a symlink in the back end. You can explicitly specify 2 or 3 depending on which one you want to use. So I'm actually still on my PL Python. That's fine. That means I don't have to switch back.
The first couple of lines that are above the projector.
They are.
There we go.
So what I had done was just a select star from PG language. Oh. If I type it correctly, I'll tab complete correctly. And that just shows what's actually installed. In very recent versions, PL PGSQL is installed by default, but we're not really worrying about that in this talk. Yeah, we did the installation slide, so I'll go back to next. So I mentioned the U in PL Python U. The U means untrusted, but it's kind of a slight misnomer. It doesn't mean that writing something in PL Python is going to corrupt your database and throw everything away. That's just mostly a security measure. Untrusted means that it's allowed to perform actions outside the database, be it make network connections or read the file system or things like that. And what that really means is that it requires super user privileges on the user account that's creating the function. The reason that you don't want to be able to do that with a normal user account is once you're able to read things from the file system or make changes to the file system, you can actually write something that could theoretically read the database structured files directly and perhaps see something that this unprivileged user is not allowed to see. So it's a avoiding privilege escalation type of scenario. Other languages, PL Perl actually has both varieties. They do it, they've got a trusted version, PL Perl and U, untrusted. They do that, I think it's a safe module which has an opcode whitelist or something like that. I don't really know the details. But unfortunately, Python doesn't have anything like that, at least at the moment. It'd be really nice if we would be able to allow unprivileged users to write their own functions, but unfortunately not at the moment. Unprivileged users can absolutely execute the functions, but they just can't define them. So, that's all good and fun, but I wanted to actually delve into some real code and just show things executing. So I've got this function out there. Called Git Timeline, and what it is doing is actually going out to Twitter and actually retrieving the last 20 tweets that have appeared on my personal timeline, as if I was going directly to Twitter, like if I can do now. It should show exactly the same thing. So what that's done, yep, there's everything. In fact, the tweet I sent out this morning using that when I was testing it is there. So what it's doing is it's leveraging the TweePy Python module. And as we get into it, I'm going to use the term set returning function, often abbreviated SRF. So if I mention that, that's what it means. So, of course, it's cutting off the top. I'll just move down a bit. Yeah, how's that? Cool. Actually, next. There we go. Keep my slide deck up to date on y'all systems. So I'm going to step through this. To create a function, we would do create or replace. The or replace is actually optional. If you're redefining a function, if you're editing one, you definitely need that, of course. But if you're creating one just from scratch, you don't need that. And we give it a name. Public is actually there by default, depending on your search path. So, oh, there we go. If we took parameters, which we're not on this one, we would give those there. And we return a set of, and as I mentioned, this is a set returning function. So we're returning a set of the type tweet. Now, when I say we're returning a set of the type tweet, I have a custom data type created. And it's actually very identical to the creating a table. And in fact, when you create a table, it creates a type of that table. So like a table definition, we've got a column, we've got the different types. For this specific composite type, I've got a screen name, status, and the created at, which is, I don't know why, yeah, it's the timestamp on the tweet. There's a number of other fields in a tweet, but just to keep it simple, I'm only returning those. So we tell it that it returns a set of that composite type tweet, and we tell it that it's using a language PL-Python, and of course we got to tell it PL-Python-U because that's its name. And inside, you guys know what this is, the $ function $. In Postgres, it's a alternate quoting character. The normal quoting character is a single quote, but of course we have those already in our code. So if we use that as the default string delimiter, then we'd have to do a bunch of escaping and all kinds of painful stuff. So a long time ago they put this in. $, most any string in there followed by a $, defines the start of a string, and that again defines the end of it. So really this is just, the code that you're seeing is really just, you're giving it to Postgres as a string, as a text. But that's where all the interesting stuff happens. So, as I mentioned, we're using the TweePy module. Just to prevent y'all from hacking into my account, I have put all the authorization stuff. Twitter uses OAuth, I think specifically OAuth 2. So it's got an API key, an API secret for the application I define, and my specific user has an access token, an access secret, and all that stuff. So this is all just the stuff that gets the Twitter speaking portion up and running. So This is where the interesting part happens. We just ask it for the home timeline for my specific user account. It puts it into I think it's basically a list of dictionaries. And once we have that, then we iterate over it. We could probably just do it there directly and not even have to worry about a variable. And then for each of those tweets, it then yields this tuple of the screen name, the text, and the created at, which is, as we saw from our composite type, that matches directly. No, I don't want to actually save that. So again, there's everything that it returns. Next, back in that, there's a few things I want to mention. We call this module, this object, PLPy. That is there in your scope by default. It is your interface to everything in the database. There is an execute method on it, and better yet, if you're passing in, which we often do, if you're passing in parameters to a query, you'll want to do a prepare and then an execute on that. I'll actually introduce that a little bit more in a little bit more detail later. And there's some messages. Well, I'll actually get into that, the message passing of that a little bit more later. Next. I also want to mention the yield versus return. In this, instead of returning a single value, question?
So you also imported that TweePy
Yes.
module. I'm curious, how do you define what environment that will be in? Like when you're giving a context, maybe I'm in a virtual environment and calling like database procedures, but I'm just curious how it knows to look in the right environment. I'm just seeing that as an issue for me if I was to set this up right now.
Yeah, it probably would. I actually intended to put how to do a virtual environment. I didn't get around to it in there, but anything that's within the Postgres' environment should work. So getting a virtual environment up and running might be a bit difficult. In this case, I'm running on an Ubuntu system, so I just did an apt-get install twitter-tweepy, and it put it into the system's Python environment. So if I just if I switch to a shell, oops, there's my slides. I have not in a virtual environment or anything. This is just running off the system's Python. It just pulls it directly from that. So that's probably the easiest way to do it. There's probably a way to get it up and running if you had a virtual environment. But
I'm guessing you just changed the path, to that virtual environment.
You could probably just.
I was just curious if there's some convenient way that went along with it, because I just know that we have a bunch of virtual environments for deployment and whatever else, and it would be rough to do it all in a global if this was the case. Yeah,
I could see that. Yeah, you could probably. Before you start Postgres, give it the environment variable for the Python path and start Postgres with that set, and it should then find everything on its own.
Thank you.
Definitely something to test and experiment with. So anyway, I was talking about yield versus return. In this one, instead of just returning a single value, we're actually yielding the individual tuples back to Postgres. But in the current version, it doesn't actually matter too much. In Python, if you're creating an iterator like that and you're yielding stuff, if you only grab so much and then stop iterating over it, then that iterator doesn't execute anymore. So if you have something that creates an infinite, some sort of infinite generator, then it works rather well in Python, but in this, unfortunately, Postgres grabs everything up front and does all its iteration into basically a tuple store. And then returns it and finishes whatever query processing it's doing on it. If you're doing like a limit or something, unfortunately it's going to grab everything that the function's running and then do the limit. I don't know if there's any easy way around that in like future versions, but I just wanted to mention that as a limitation. So anyway, now that we have it there and running in the database, as you saw, we can do a select from it, and it acts just like a table. We could, where did my select go? We could do a where limit on it. We're screen. Show only the filter for the tweets that I'm doing. We could do calculations on the field. Actually, for example, this. We're getting the screen name. We're calculating the length of the field of the status, and then doing a summation on it. And then we're doing a group by screen name. So what we're doing is, in essence, showing the most vocal people in my timeline as of very, very recently. And apparently the EFF tweets quite a bit, and they do. So we can do all kinds of things with that in there. And if we don't really want to do the Git_timeline, we can actually wrap that in a view. Create view timeline as select. And that looks even more like a table. So, well, that's all fine and dandy, but you can really do that outside the database, right? I mean, if you really wanted to, you could run that as a script and update it, import it into the database periodically. But sometimes you really, really do need that up-to-the-moment data. And as we mentioned, as the talk earlier mentioned, if you're doing that frequently but not really paying attention to the data, if you're not really looking at it that much, then it's a lot of wasted cycles. It's a lot of wasted cycles of updating, a lot of database churn that's not really needed. So, all right, that's fine. Let's do something a little bit more interesting then. Let's make a trigger. So, a trigger is actually a two-step process. If any of you were in the talk earlier, you kind of saw that, but we'll go through that again. Step one for creating a trigger, we would do we actually need to create the function, and step two is linking that to whatever we want to do. So, the trigger function, let's go ahead and, I was going to do this from scratch, but because of all that OAuth stuff, I'm going to cheat a little bit and do okay, yeah. So I'm going to delete our Git timeline, and we're going to call it, I don't know what we want to call it. I've already got one, okay, new tweet, so update status. Instead of a set of tweet, a trigger returns a special type, appropriately called returns trigger. Our language is still PL Python. All the boring stuff, the OAuth stuff, we'll just skip over. So, I should also mention that triggers don't, by necessity, the argument list has to be empty. And to compensate for that, the arguments that you can give it are returned in in PL Python. you get by default in the scope, in addition to your PLPy object, you get an object called TD, which is your trigger dictionary. And that has all kinds of information about the trigger. The operation that kicked off the trigger, the table that happened, if you link your trigger to multiple tables. It has additional arguments, and in the case of what we want to do with it, it actually has new and potentially old tuples that represent what we're acting on. So, what we really want to do is Twitter API.update status, and the new tuple will itself have a list of different columns we have. So I think we called that, oops, we just called that status. That's simple. And the return type is often going to be either none, or I think there's a special string OK, which basically means the same thing. So, I mean, apart from our OAuth stuff, we've really just given it 2 lines in our import. So if I've done it right, we should get create function. Yeah, okay, excellent. Now, as I said, we've got a 2-step process. So now that we've defined the function, what we have to do is tell it that you can do all kinds of stuff with triggers. I think in past examples, I've set it up so that if an account, like if you had a simple financial application, if an account level gets to below a certain point, you could send out an email notification using SMTP-lib or something like that. If you were in the talk before, you could do a notify on things. You can do all kinds of stuff. But in this one, that view that we just created, which is really just a wrapper on that, what I want to do is give it the ability to write to that. So we'll say create trigger, and we need to give it a name. It could be anything. Trigger, update status, timeline, it doesn't matter. And when do we want it to happen? We want it to happen by the way, I hate SSHing on Android. It is very, very laggy. We could have it do it either before or after, or we could have it do it instead of an action, and we want it to happen instead of insert on, what did we call our view? We called it timeline. Let me tell it, we could either tell it for each, the different options for that is we could have it execute for each row, which we want for this time, or for each statement, and the usage of that is slightly different. If you've got a big batch process and you want to run the trigger once for that, you would run that for each statement. If you want to have it process each row of a big batch process, like most likely for like that notification example, we would do it for each row. So we would then, for each row, execute procedure. I believe I called it update status. And as I said, if you want to, let's see, does that wrap properly? It looks like it. If you wanted to give it any more parameters, you could actually do that at that point, and it would appear in that trigger dictionary. Dictionary. So anyway, so our trigger is now created, and if we take a look at our view timeline, we'll see it down there. It says instead of insert on timeline, then it will execute this procedure. So what that will let us do is insert into timeline. Remember, we're only really looking at the status field, so the other ones I can really just ignore. If you wanted to, you could probably do something where you looked at the screen name and pulled different OAuth tokens for those, but I didn't, just to keep the example simple. And if I do this correctly, I don't get an error. There it is, very top. And if you're actually following me on Twitter, you actually just saw that. So, fun stuff. All right, cool. So, admittedly, that's kind of a it's kind of a fabricated example, just for the sake of showing what it can do. Does anything use it for real? Of course. Well, for those of you that are actually following along on the slides, you see me executing this next function. We're actually using PL Python to control that. So I'm going to actually run through how this application works. So yeah, actually have a couple different helper functions for this. We've got next, previous, go to, slide. I actually haven't used any of those latter at all. So let's take a look at next. So instead of our composite type, we're just returning a simple type text, and we're not doing a set returning function or anything like that. It's just returning that single value. So our next slide, this is kind of a complex, well, I don't know if it's really that complex of a query, but what we're really doing is looking at, I've got a table out here. It's really just, it lists all my different slides. It doesn't really matter too much because, I mean, it's not driving the presentation at all. It's really just for the reference of the application. So we're getting the ID, HTML ID, title and body for basically my slide notes. And we got, and from our slide table, we look at the current state of the presentation. We figure out what is the next slide and all that stuff. So, what is this line? Oop, I went too far. What is that one? If you've watched what it actually outputs, it actually has a little timer at the very bottom. So I'm targeting about 10 minutes before the hour I want to be done. So it's actually telling me how much time I have left on this talk. So if I do, I go back a slide. I've got about 15 minutes left. Is how much longer I want to keep talking. Actually, I probably want to end it a little bit earlier than that. So, to continue on, if for some reason I tell it to go next and we're already at the end of the presentation, it'll return 0 records for that query. And it says, sorry, no, you can't do that. And so we give it an error. And the PLPy object has the ability to send messages back to Postgres. It could be an error, it could be critical, and those two will abort the transaction if you're in a transaction. So that's if something really, really bad happens and there's no way to recover from it. We could also give it a warning, which warning, info, or debug, and by default only a few of those actually appear to the client, and some of them appear to the log. So check the manual for the different levels of logging, but anyway. So, and as I mentioned, if we're doing something with parameterization, it's kind of a two-step process there. We give it a plpy.prepare, and give it the query that we want with parameters that we want it to fill in later, and it returns a little object that we then hand back to execute, and to that we give it the different variables we want it to fill in, and it takes care of any quoting issues or anything like that just under the hood. You don't have to worry about quoting at all. In addition to, you can use that same prepare object and run multiple executes against that. So if you're running the same query a bunch of times for some reason, a bunch of inserts or a bunch of deletes or anything like that, that saves a little bit of time so that it doesn't have to keep reparsing the query and figure out what you want. It's already parsed it, and it just fills in the values and then executes. Sometimes it doesn't really work, and sometimes you might not want to do that. So the POPI object also gives you the some built-in functions to quote objects, quote variables or literals or things like that. So it takes care of that, including the string wrapping portion. So if you're in the talk earlier or before this, and you went saw the notification and listened and all that stuff, then you're familiar with that already. If not, it's Postgres has an asynchronous notification system built in, and because the talk before that went into all that, I could actually save a few minutes from having to describe all that. And if you weren't in it, just go and watch the video, because it was a fantastic talk. So, and I'll show in a minute what that actually does. And then, as a return, it just shows basically me up here. It shows the notes as far as what slide it's actually showing you on your laptops or whatever, and how much time I have remaining. So, very, very simple. Previous is the same function is almost identical, except it just figures out what slide is before that slide, and the last one I mentioned, go to slide, which I actually haven't used yet. It's actually an overloaded function. So I could either pass it an integer, in which case it finds the slide by number, or I could pass it a text, in which case it finds the slide by the HTML ID. If you pay attention to the slide deck, it actually will change the ID in the URL, so you can actually bookmark these specific slides directly. But same function name, it's just different argument types, and those, if you really needed it to, those functions could do very, very different things based on just giving it different argument types. So that's an example of an overloaded function. So I want to take a look at the back end. Incidentally, if you actually are following along, the site is connecting to this very system that we're on. So the app that runs it it's mostly, the slide deck is actually all static. It's all static HTML, CSS, JavaScript, and the dynamic portion actually comes from two different Flask routes. So the least interesting one is the state, and what that really does is the slide deck will ask, is this presentation really going on at the moment, and is this something that we really, the JavaScript is just checking to see whether or not it should even bother to look at our event stream. The live route is where all the interesting stuff happens. So rather than do, as a presentation before this mentioned, a WebSocket, what this is doing is a long polling type of scenario. What we do is we return a responsive type text event stream. And what that does is the browser will connect to that and then wait for data to come in. And it's somewhat free form. And, well, anyway. So what we've given it is response, and then we've given it a generator that's returning basically a set of text responses. So that's this. What we're doing, if you were in the talk before this, it actually looks very, very similar. We're making a connection, returning auto commit on so that it gets the notifications immediately. We're giving it this little, we're using PsychoPG to connect in, and we're giving it this little PsychoPG extras, a dictionary cursor. By default, if we run a query, like, where's the query? Like here, or here. The result it gets back is a list of lists. And if you want to refer to a field by name, well, you kind of can't. So this little psychopg.extras handy feature returns a list of dictionaries, so that we can, at that point, instead of returning a list of lists, we can then refer to that that field directly by its name. So a little bit more self-documenting. So we set up our listener. When the browser connects in, it sets up a listener for the slide movement, and once again checks the current state and immediately sends a response what the current state is and what the current slide it's paying attention to. The event stream format basically is the word data, colon, any type of text. In this case, we're serializing some JSON. And then 2 character returns. So it's a blank line, and that tells the browser that it's done receiving this event and that it should then wait for the next one. So we send the first one. Make sure we got enough room. And it's for basically forever. Not quite forever, but while the presentation state still says it's ongoing, then we do this long loop. Select, if you weren't in the talk before this, is a very lightweight wrapper around the operating system function select. Select has been in there for a long, long time. It is a way of multiplexing I/O on various sockets. So we give it 3 lists and a timeout. The first list is sockets we might want to read from. Second is anyone we might want to write from. And if it's not available, then it'll wait for it to become available. And the third one is anyone that we might want to pay attention to as far as having an exception. And we check it for empty list returning. And what that means is this 5-second timeout I have here, if we get no response back, then we know that 5-second timeout has happened, and our event stream is not actually ready. So what we do at that point is we send a heartbeat. The heartbeat is really just for the system's health, because if we don't and your browser disconnects, then the system doesn't actually notice for quite a while, and I have a connection sitting open for who knows how long, but that's okay. And we check our presentation state table again to see if, well, are we still actually doing our stuff? If we actually did get a response, and it says that there's notifications waiting, we do a poll. It gets those. It gets what has actually been sent to it, and then it serializes that back into a JSON object and sends it to your browser, and your browser then acts on it accordingly. The only case when we fall out of this loop is if I set that table that says ongoing is false, which I'll do after the presentation is done. It'll fall out of the loop. Tell your browser that it's actually done, and your browser will go, okay, I'm done. I'm not going to pay any attention anymore. So, anyway, the JavaScript side. I'll actually admit now that we've gone through all this. This slide deck I mostly stole from Google. They had a nice HTML example, HTML5 demo, and they put all the code for that, all the CSSs as an Apache license. I was like, oh, that looks really cool. So I got it and kind of shoehorned in all the event stream stuff that actually will drive the presentation remotely. So that's kind of for a later day. We're running a little bit short on time, but that's fine because we're right at the end. Any questions?
What kind of protection does Postgres put in place for, exceptions that pop up or anything like that? Is there what kind of isolation, sandbox type of thing does it have going on?
One of the things I didn't actually mention is that there's the PLPy object has an exception that you can trap with PL/Python. If something happens in the database, if you try to delete something on a table which you don't have permission, or some other exception happens, you can actually trap that and do some recovery of it without automatically rolling back your transaction. As far as protections against, like what would be something bad that would happen? Accidentally deleting a database file that?
Just an exception propagating up through, is it isolated to just the transaction it's working on? Does it affect the server in some sort of way?
It is isolated to the transaction it's working on, unless you're doing something shady like affecting the memory space of Postgres directly or something like that. There are ways, like I said, that, because of that protection, you have to have super user privileges to create a function, and that's one of the reasons that you can't actually, in theory, get access to the Postgres memory space or to the files or something like that and wreak some type of havoc. But if you're doing something normal, then yeah, if you have an exception, if the Twitter API didn't return a response, it would just come back and it'll return an error. Actually, it will give you a trace back, and it'll just abort the transaction and move on from there. So, one other question?
Do you notice any performance difference between some Python script that's triggered from inside the database and one that gets triggered externally with notifications?
Python on the inside versus Python on the outside? Probably not. It depends on how far away the Python on the outside is. If it's on the same system, then it's probably going to be reasonably close. If you're communicating across servers in a rack, it's probably going to be fairly similar. If you've got one in Australia and you're communicating to a Postgres in New York City, then yeah, it's going to take a little while, just based on the round trip time. But in general, apart from the round trip aspect of the communication between the database and the Python, it's probably pretty similar. It really is executing the same. It's not like it's a separate interpreter. It's grabbing the same Python shared libraries and all that stuff and running in that context.
So I'm curious, after these two, I went to the last Postgres talk too, and like learning about the notifications was like really cool.
Yeah.
And I'm curious because you did the same, like basically syntax and like, you had your notification, but what's the advantage to having PL Python? I think it's cool, but I'm curious, like, I mean, I think of like, what if you have to like unit test that, or you have to go and, do something, it's kind of tough because I'm curious like how that works. Like you said before with an exception, if that gets raised and then it rolls back that transaction, what if it's like someone just, I know it's a super user, so you should trust them, but we're all human.
Right.
Like if we make an error, the exception is raised, and then like all the transactions until we fix that error could be just completely like, garbage. Like we just miss it.
It's possible. Yeah, definitely. Like anything that involves a database, and your unit testing framework should have some sort of connection into that. So you might not. I don't know that you could really do any imports of like a unit testing framework with it in it directly, but certainly integrate it into your testing structure.
So its use case would probably be more or less things that aren't like dependencies. Like let's say TweePie like updated
Right.
and something went wrong. This would be a bad place to have an exception be thrown. I feel like it's written
Probably.
here.
Yeah, probably. If you're not paying any attention, hopefully you've got some sort of monitoring on the database that says that's watching the logs and saying, oh, I've got a bunch of these errors that's happening now, and it sends off an email. I probably shouldn't mention too much because it's all written in Perl, but Bucardo.org has a bunch of utilities for that. It's got a tail-mail, which will actually watch a log, and if it sees any exceptions, it'll send off an email right away. So something like that could possibly be used to at least mitigate that happening. Or staging environment, where you're testing any package updates or anything like that.
Okay, we gotta head out.
Yes, okay. Time's up.